Good morning. It's January 7th, and this is your daily brief in science. Here's everything you need to know. New research published on January 6, 2025, in the Proceedings of the National Academy of Sciences reveals that extensive silver mining in ancient Rome likely led to significant lead pollution, which had a profound impact on the population's health. This study employs lead isotopes to trace pollution back to specific historical mining activities, marking a novel approach in pollution research. This research is the first clear indication of widespread industrial pollution in history, demonstrating human impacts on the environment dating back 2,000 years. Researchers utilized ice core samples and atmospheric modeling to estimate lead levels, linking them to cognitive impairments observed in the Roman population. While the findings indicate significant lead exposure, the study acknowledges limitations in directly linking ice core data to human health outcomes and IQ metrics. Nevertheless, it estimates a reduction in IQ levels of at least 2 to 3 points among the European population due to lead exposure, which is associated with cognitive decline. The findings highlight the substantial environmental impact of Roman industrial activities on public health and intelligence. Experts suggest that this research could reignite discussions about lead's role in the decline of the Roman Empire, although it was likely one of many contributing factors. Additionally, the study establishes connections between lead pollution and historical population declines associated with plagues and pandemics. Lead is recognized as a neurotoxin with no safe exposure level, linked to various health issues, particularly affecting cognitive development in children. Understanding these links between pollution and health impacts in ancient Rome can provide valuable insights into contemporary environmental challenges, especially as lead pollution in the U.S. has been described as the longest-running epidemic, significantly affecting the IQ of the population since the 1940s. Researchers at the University of Michigan have unveiled a revolutionary method for detecting circulating tumor cells in the bloodstream of patients with pancreatic and lung cancer. This advancement aims to enhance treatment outcomes for these challenging cancers, which often suffer from late detection and low detection rates. The study was published on January 6, 2025, in the journal Biosensors and Bioelectronics. Pancreatic cancer is notorious for its poor prognosis, largely due to late-stage diagnosis, while lung cancer faces similar challenges, particularly during recurrence. Traditional detection methods typically involve labeling proteins on tumor cell surfaces with fluorescent dyes, a process that can miss certain cells and often destroys them for further analysis. In contrast, the new technique employs biolasers to stain the nuclei of the cells without killing them, enabling live detection and analysis of circulating tumor cells. After isolating the tumor cells, researchers utilized laser excitation, which produced stronger emissions compared to conventional fluorescent techniques. This allowed for detailed imaging of the cell's shapes and DNA organization. Blood samples from pancreatic cancer patients were initially processed through a circular maze called labyrinth, designed to separate circulating tumor cells based on size. The research team achieved an impressive 99% accuracy rate in identifying pancreatic cancer cells using a deep cell laser classifier model and successfully identified lung cancer cells without additional training. Professor Zhudong Fan noted the advantages of laser emissions, which present cells in a more informative manner than traditional fluorescence. The team aims to analyze light patterns from these cells to gain insights into tumor aggressiveness and treatment resistance. Future developments include the creation of a device to isolate and collect detected cancer cells, ensuring they remain available for further analysis. Professor Sunitha Nagrath emphasized that the interdisciplinary nature of the research was crucial for its success. A recent study conducted by the University of Cambridge and Fudan University sheds light on the biological mechanisms that link loneliness to various health issues. This extensive research monitored the health of over 42,000 participants for approximately 14 years, uncovering significant connections between loneliness and serious health conditions. The study revealed that more than half of the proteins identified were associated with critical health risks, including cardiovascular disease, type 2 diabetes, stroke, and overall mortality. Notably, 5 specific proteins, GFRA1, ADM, FABP4, TNFRSF10A, and ASGR1, were found to be elevated in individuals experiencing loneliness, indicating a potential biological basis for the health impacts of social isolation. These findings are consistent with prior research that links social isolation and loneliness to increased disease risks, including a 26% higher risk of dementia among socially isolated older adults. The research highlights the importance of social connections in promoting health by reducing stress, enhancing immune function, and improving cognitive abilities. While the study emphasizes the role of proteins in the loneliness-health relationship, it also recognizes that factors such as social stress may play a significant role in these health outcomes. Blood samples from participants aged 40 to 69 were analyzed, providing a comprehensive view of how loneliness correlates with specific protein levels. Despite advancements in technology that facilitate communication, superficial digital interactions can exacerbate feelings of isolation. This underscores the necessity for deeper, meaningful relationships. Human beings thrive on connection, making it crucial to address loneliness and social isolation for overall well-being. Face-to-face interactions, which involve nonverbal communication, are particularly effective in strengthening social bonds and enhancing emotional health. According to the World Health Organization, about 25% of older adults experience social isolation, while 5% to 15% of adolescents report feelings of loneliness. The research team, led by Chun Shen from the University of Cambridge, included input from senior researcher Jianfeng Feng from the University of Warwick, emphasizing the collaborative nature of this significant study. A recent breakthrough in kidney injury detection could change the landscape of patient care. Findings published on January 6, 2025, in the journal Clinical Pharmacology and Therapeutics, led by Dr. Sushrut Waikar, reveal the identification of 6 new biomarkers that enhance the speed and sensitivity of kidney injury detection. These biomarkers are produced by the kidneys in response to injury or inflammation, allowing for earlier detection than traditional blood tests, such as serum creatinine. The ability to detect kidney damage at an early stage can lead to timely clinical interventions, which may reduce long-term damage and improve overall patient outcomes. Drug-induced kidney injury or nephrotoxicity is a common issue in clinical practice, often resulting from medications like anti-inflammatory, antibacterial, antiretroviral, and chemotherapeutic agents. The complications caused by nephrotoxicity can lead to the discontinuation or restriction of essential therapies, significantly limiting treatment options for patients. The research involved measuring urinary levels of these protein biomarkers in healthy volunteers and patients undergoing chemotherapy for mesothelioma, a drug known for its nephrotoxic effects. The team is now focused on assessing the broader applications of these biomarkers for monitoring kidney health in clinical trial settings. Waikar also serves as a consultant for nephrotoxicity biomarkers for several companies, including Vertex, Pepgen, and Ikena. Current biomarkers often fail to indicate early kidney injury in a timely manner, whereas the newly identified biomarkers can be detected in urine and may reveal damage within just 24 hours. Tuberculosis, or TB, continues to be the leading infectious disease killer globally, with multi-drug-resistant TB, known as MDR-TB, posing a significant threat to public health. Each year, over 10 million individuals are diagnosed with TB, resulting in approximately 1.25 million deaths, particularly in regions like India, Central Asia, and Southern Africa. In response to the escalating threat of MDR-TB, the World Health Organization endorsed a new 6-month treatment regimen called BPLM in 2022, which has shown improved safety and efficacy. However, a recent study conducted by the Swiss Tropical and Public Health Institute has raised alarm bells, indicating that resistance to this new treatment is already spreading among patients. The research analyzed nearly 90,000 M. tuberculosis strains worldwide, and found 514 strains resistant to TB drugs, with a concerning 28% of these resistant strains transmitted directly between patients. Alarmingly, despite the overall number of resistant cases being relatively low, the transmission rate is troubling just 2 years after the introduction of the new regimen. In 2022, only about 40% of individuals diagnosed with MDR-TB received appropriate treatment, highlighting significant gaps in care. These findings emphasize the urgent need for public health policies that integrate the deployment of new drugs with robust surveillance systems to combat antimicrobial resistance. Experts stress the importance of enhanced diagnostics, infection control, and surveillance systems to prevent the emergence and spread of drug-resistant TB strains. Despite advancements in TB drug development, there are serious concerns that M. tuberculosis will continue to adapt and evade these treatments, necessitating proactive measures to avert a potential post-antibiotic era for TB and other diseases. The urgency of addressing antimicrobial resistance is further underscored by the need for comprehensive strategies to tackle this evolving threat. TB, caused by Mycobacterium tuberculosis, spreads through the air and presents symptoms such as coughing, chest pain, weight loss, fever, and night sweats. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.